Good morning. We are going to pass on to the next portion of Module 5, Simple Harmonic Motion. Simple Harmonic Motion, usually written as SHM. So you are familiar with what is periodic motion. Any motion which repeats itself at equal interval of time is called a periodic motion. That is a motion like this. If you plot as time process, the displacement, if you plot it like this, any motion which repeats itself at regular intervals of time is called a periodic motion. And a periodic motion becomes simple harmonic motion. It should satisfy two conditions. One, acceleration of the particle should be proportional to distance from mean position. That is, A should be proportional to x. Second condition is acceleration of the particle should be directed towards the mean position. So acceleration should be proportional to the distance from mean position, and the acceleration should be always directed towards the mean position. So let us see this. A body, say a particle P, is rotating or moving along the circumference of a circle of radius r with uniform angular velocity omega radians per second. So it starts from this position and it moves with angular velocity omega. Say after a certain time it is moved to an angle theta. So the point P at theta with this horizontal. Now, projection of this point P, M, is the projection of P on this horizontal diameter. So as the point P moves from A to B, the point M moves from A to O, then to B. Okay, as it moves from here to here, the projection of this point comes like this. So it moves from A to B. Then as it moves from B to A, the point P moves from B to A, the projections on this horizontal axis, it will move from B to A. The point M will move from B to A. So for one full cycle of rotation of point P corresponds to one stroke from A to B and then another stroke from B to A. So this midpoint is called the mean position. So distance of this point M from the mean position is marked as x. So the acceleration should be proportional to the distance from mean position, and the acceleration should be always directed towards the mean position. So the direction of acceleration will be always towards the mean position. So these are the two conditions for a periodic motion to be simple harmonic motion. Now let us see some derivations or some equations which we have to use for solving the numerical examples. So let us consider the point P. Its projection is M. It travels through angle theta. So it travels with velocity, angular velocity omega. Say from this extreme position, I count time t is equal to 0. I'm going to count time t is equal to 0 when this point is at A. And when it reaches t, the time is equal to t seconds. After t seconds, it reaches t, P point. So what is theta? Theta is equal to omega t. The angular displacement theta is equal to omega t. Or what about x? This x is equal to, this is r, is the radius vector, which is called the amplitude. The maximum displacement of this point is from O to A. That is amplitude of motion. Or x is equal to r cos theta, looking into this triangle. OM, the displacement from mean position, is equal to r cos theta, or it is equal to r cos omega t. So when I take the time as 0 at extreme position, consider the travel. The displacement at any time is an expression connecting the amplitude r and the angle traversed theta, or x is equal to r cos omega t. That is one important expression. Always displacement is measured from the mean position only. Now, if x is the displacement, the velocity of this point M, velocity is rate of change of displacement, dx by dt. So differentiating this, r sin omega t cos omega t minus sin omega t into omega, r omega sin omega t. Let us find out what is sin omega t, sin theta. Looking into this, sin theta is equal to opposite side divided by hypotenuse. This is r, this is x. So this side will be root of r square minus x square. Isn't it? Root of r square minus x square divided by r. That is what is written here. So sin theta is equal to root of r square minus x square by r. So v is equal to, in this expression, substitute sin omega t, this one, the r and r gets cancelled. So v is equal to omega into root of r square minus x square. This is the expression for velocity. So if you know the amplitude, the displacement from mean position, we can find out the velocity. Here, velocity is negative. Negative means as the time increases, the displacement decreases. See, as time increases, when the time is equal to 0, this was the displacement, maximum displacement. As time increases, this becomes OX. Again, as it increases, the displacement decreases, as well as velocity also decreases. That is negative sign representation. Now, coming to acceleration, acceleration is dv by dt. So here, r omega, sin omega t, differentiation is cos omega t into omega. So it becomes r omega square cos omega t. Now, we know x is equal to r cos omega t. So r cos omega t, except this omega square, this r cos omega t can be replaced with x. So acceleration is equal to minus of omega square x. That means the acceleration is proportional to the displacement from mean position. And negative means as x is increasing, acceleration, the direction of x, we are measuring from the mean position. From here, we are measuring the displacement. Displacement is measured from the mean position. Acceleration is negative means acceleration is opposite to the direction of x. So acceleration is directed towards mean position. Or if you write it as an differential equation, acceleration is nothing but d square x by dt square. So I can write d square x by dt square plus omega square x is equal to 0. So this is the expression representing simple harmonic motion. The differential equation representing simple harmonic motion is d square x by dt square plus omega square x is equal to 0. If you can get in practical cases any motion which can be represented in this particular form, that will be representing a simple harmonic motion. So acceleration is proportional to x and it is directed towards the mean position. What you have seen so far is the expression for displacement x is equal to r cos omega t when the time of motion is measured from the extreme position A and the velocity v is equal to omega into root of r square minus x square and a is equal to minus omega square x. So if you know these three equations, we can solve any type of examples in this simple harmonic motion. Now coming to next one. So we have the expression v is equal to omega into root of r square minus x square. From this we can arrive at certain conclusions. If you put x is equal to 0, so when the particle at mean position x is equal to 0, v will be equal to omega r. Now the maximum velocity is omega r when the particle is at the mean position. When x is equal to r, that is when the particle is at the extreme position, when x is equal to r, the velocity becomes 0. Similarly, considering the expression for a is equal to minus omega square x. When x is equal to 0, acceleration is 0. At the mean position, its acceleration is 0. And when x is equal to r, at the extreme position, acceleration is maximum minus omega squared r. Now we have seen the time is measured from the extreme position. What will happen if the time is measured from mean position? We can have two references. See, in this case, we have seen time is starting reference is 0. In certain question papers, they may give the time is 0 when it is at the mean position. When the time has this reference, time is equal to 0 at this mean position. As the particle P is traveled time t seconds from the mean position, we have to make use of this. We have to measure this along this y direction. When the time of reference is from this particular point, then theta, the displacement along the y direction or along the vertical axis, x dash, o m dash, the projection of p on this. So this theta is equal to omega t. Time when it is equal to 0, it is t. So the motion, this angle is theta. So this x dash is equal to r sine theta. We have to make use of the expression x dash is equal to r sine theta. So if m dash is the projection of the particle on the vertical line CD, displacement from mean position x dash is equal to r sine theta or r sine omega t. So then velocity v is equal to dx by dt, r omega cos omega t, and acceleration is equal to r omega square sine omega t. Here we will substitute for cos theta. Looking into this cos theta, if you take cos theta is equal to pm dash divided by r. Pm dash is nothing but root of r square minus x dash square. So here also substituting r square minus x square by r, v is equal to omega into root of r square minus x square. Now v is equal to omega into root of r square minus x square. Acceleration, x is equal to r sine omega t. So r omega sine omega, r sine omega t substitute for x, a is equal to minus omega square x. So when the time is measured from the mean position, time of motion is measured from the mean position, that is at t is equal to 0, the particle is at mean position, then the expression for x dash is equal to r sine omega t. That is the only change. So make use of this two expressions. When the time of reference, that is time has two different references. Either it can be measured from extreme position or it can be measured from mean position. If it is measured from extreme position, x is equal to r cos omega t. The time is measured from mean position, it is x dash is equal to r sine omega t. And the expression for velocity and acceleration remains the same, not changed. Certain terms connected with the simple harmonic motion. Amplitude. Amplitude is maximum displacement from the mean position. And period of oscillation means time taken for one complete cycle. Time for one rotation is called period. It is expressed in seconds. Frequency means number of, suppose it repeats like this. One cycle means from the mean position goes to the extreme, again comes to the other extreme, then reaches here. So time from here to here. This is one period. One cycle, time for one cycle is period. Number of cycles or number of oscillations in 1 second is unit is cycles per second, that is called hertz and is called the frequency. The frequency of oscillation is number of oscillations made in 1 second, that is equal to cycles per second, and the unit is hertz, and frequency is 1 by time period. And we have the relation, if it is moving with omega velocity, the particle is rotating at angular velocity omega, the time period is t, omega is equal to, in terms of time period, omega radians per second is the angular velocity. If t is the time for one full cycle, omega into t will be 2 pi radians, one cycle. Omega into t is 2 pi radians, or we can get the angular frequency omega is equal to 2 pi by t. 2 pi by t, or 1 by t is f, so omega is equal to 2 pi f. So these are some equations which we have to use in numerical examples. In the next video, we'll see the numerical examples from simple harmonic motion. Thank you. Okay, we have discussed in the last introduction to simple harmonic motion, the different equations to be used and the concept of simple harmonic motion. Now passing on to the numerical examples. The first question, a body moving with simple harmonic motion has an amplitude of 1 meter and period of oscillation 2 seconds. Find the velocity and the acceleration of the body at t is equal to 0.4 seconds when time is measured from mean position. And second case, when time is measured from extreme position. So let us see case 1, the time is measured from mean position. So when the particle is here, the time t is equal to 0. So we have to consider the point P, and we consider this vertical diameter, and accordingly this is theta. So this is x dash, this is x, distance from mean position. We project it, x is equal to r sine theta, or x is equal to r sine omega t is the expression to be used. When the time is measured from mean position, x is equal to r sine omega t, where r is equal to 1 meter, that is the amplitude 1 meter. Period of oscillation 2 seconds. So period of oscillation 2 seconds means time period 2 seconds. From that we get the angular velocity omega. Omega into t is 2 pi radians. So omega is equal to 2 pi by t. So from that we get the angular velocity pi radians per second. And the time considered is 0.4 seconds. So omega into t, pi into 0.4. So pi into 0.4, you convert it into radians per second. This is in radians, you convert it into degrees, so you multiply with 180 by pi. That is pi radians is equal to 180 degree. So this is pi into 0.4 is in totally in radians, into 180 by pi will give it in degrees. So R1 sine 72 degree. Or if you if you put it in 0.4 pi, you put it in the radian mode. So you'll get the distance, displacement from mean position. Velocity equals omega and root of r square minus x square. Omega is pi, r1, x 0.95 meters. So you'll get the velocity. What is the question? Find the velocity and the acceleration. Acceleration is equal to omega square x. Omega is pi square x. X is r sine omega t. So we'll get the acceleration 9.38 meter per second square. The same problem when the time is measured from extreme position. So when time is measured from extreme position, this is the reference for time. Time t is equal to 0. So this will become theta. So the projection of this point, this is x. We'll measure x from the mean position. X is equal to r cos omega t. So use the expression x is equal to r cos omega t. We'll get the displacement. V is equal to omega and root of r square minus x square. And acceleration omega square x. Very simple example, commonly asked in university exam. So when the time is measured from mean position, x is equal to r sine omega t. Time is measured from extreme position, x is equal to r cos omega t. Just remember these two. Second question. A body moving with simple harmonic motion has velocities 10 meter per second and 4 meter per second at 2 meters and 4 meter distance from the mean position. Find the amplitude and time period. So V is equal to 10 when x is equal to 2 meters from mean position. So we can write V is equal to omega into root of r square minus x square. So V square is equal to omega square into r square minus x square. V square is equal to omega square into r square minus x square. Second case, velocity is 4 and the distance is 4. So velocity is 4, distance is also 4. Omega square into r square minus x square. So we have got two equations. 1 by 2. Do 1 by 2. 10 square by 4 square. R square minus 4 by r square minus 16. Solving you get the amplitude. So first part is over. What is time period? Second part is time period. If you want time period, we can find out the angular frequency and from that we can get it. So substitute this r in any of these equations. Substitute r in this first equation. 10 square is equal to omega square into r square minus x square. So from that we get omega. Once we get omega, we have the equation t is equal to 2 pi by omega. So the time period is 2.38 seconds. Such questions are very common in university exam for 8 marks or 7 marks. To pass on to the next question. A particle moving in simple harmonic motion performs 10 complete oscillations per minute. So 10 oscillations in 1 minute. So number of oscillations in 1 second is called the frequency. Number of oscillations per second is called the frequency. So 10 per minute. So 10 by 60. 1 by 6 hertz is the frequency. Once you get the frequency, the time period is reciprocal of frequency 1 by f. So it is 6 seconds. And the angular frequency omega. Omega can be either obtained as 2 pi by t or omega is also equal to, you can use this 2 pi f. Omega is equal to 2 pi into f. So f is 1 by 6, 2 pi into 1 by 6, we'll get omega. Okay, so time period is given, we can calculate the angular frequency. If angular frequency is known, we can calculate the time period, vice versa. The speed at a distance of 150 millimeter from the center of oscillation is 3 by 5 of maximum speed. Given a particle is performing simple harmonic motion, 10 oscillations per minute. So from that we got number of oscillations in 1 second, and we have got the time period. And the speed at a distance of 150 millimeter from the center is 3/5 of maximum speed. Find the amplitude, maximum acceleration, and speed of the particle when it is 100 mm from the center of oscillation. So when x is equal to 150 millimeter, the velocity is 3/5 of maximum. So v is equal to omega into root of r square minus x square. Substitute omega we don't know, r square we are not known, x square is 0.15 square. That is equal to 3/5 of maximum velocity. Maximum velocity v is equal to r omega. Maximum velocity is r omega. So this omega gets cancelled. 3/5 of r is equal to omega r square minus 1, squaring both sides. R square minus 0.15 square is equal to 3/5 square into r square. So get an expression in r square. Solving it will get r, the amplitude. Once we get the amplitude, maximum velocity is omega squared r. Omega v is equal to maximum velocity. No, it is maximum acceleration. You are asked to find out the maximum acceleration. A max is equal to omega squared r. So omega squared into r will get the maximum acceleration. See, the question is find the amplitude, find the maximum acceleration. Then speed of the particle when it is 100 mm from the center. So when x is equal to 100, what is the velocity? So v is equal to omega into root of r square minus x square. Omega is known, r is known, x is equal to 100. So you get the maximum or the velocity when x is equal to 100. So all are direct substitution questions. A particle moving with simple harmonic motion has an amplitude 4.5 meter. Amplitude means distance from the mean position, 4.5 meter. The period of oscillation 3.5 seconds. Find the time required by the particle to pass 2 points which are at distance of 3.5 meter and 1.5 meter from the center and on the same side of the mean position. So this is the mean position, amplitude. So OA is 4.5. Distance to pass between 2 points, 1.5 meter and 3.5 meter. So we are asked to find out what is the time taken for this much travel. So this is x. Let us write x is equal to r cos omega t. That expression will be, here the time is measured from extreme position. The expression is x is equal to r cos omega t. Let t1 be the time taken to travel for 1.5 meter. Time taken to travel 1.5 meter is, say, x1 is equal to r cos omega t1. You can write x1 is equal to r cos omega t1. This expression, this is in radians. From that you get what is cos omega t1 is equal to 1.5 by 4.5. So 1.75 t1 is equal to cos inverse 0.33. We'll get t1. Similarly, 3.5 is equal to r cos omega t2. From that you get t2. So difference between the two will be the time taken. So the time to pass the 2 points is 0.307 seconds. See, the time is measured from extreme position and the distance is always measured from mean position. So time taken to travel between these 2 points is 0.37 seconds. So these are some typical examples from this portion, and I'll stop for the day.